Hello, my name is Mohammad Haris Iqbal. Today I will be talking about network packet crafting and analysis. First, I would like to give a disclaimer. The contents of this video is for educational purposes only. I will be starting from packet analysis and then will move on to more advanced topics such as packet crafting. Packet analysis is a way of capturing packets from different network interfaces. The process taps in from the network and captures live packets in raw data format. This is then presented in a proper readable format, and by format I mean the data is divided into proper network protocol layers. This makes it easier for users to read and interpret the packets. Packet analysis technique is used by different people for different purposes. Network admins use it to detect problems in their servers. This is usually done by capturing targeted packets or crafting custom packets to test specific services. Any malicious attack is mostly carried out through the network. There are techniques which can be used to detect such attacks using packet analysis. Students can also use packet analysis technique to see the network protocols in action by capturing live data packets. First and the only thing that you would need for packet analysis is a tool. There are a number of tools available in the internet, both free and paid, proprietary and open sourced. Few that are famous and are widely used are Wireshark, TCP-Dump, Microsoft Network Monitor, and others. Wireshark is the most popular and widely used tool for this purpose, mostly because of its large number of different features and friendly user interfaces. Another one that stands out of the crowd is Sniff Password Sniffer. It captures only those packets which contain usernames and password. Now I will demonstrate packet analysis using one of the tools called Wireshark. Once you start Wireshark, this is the screen that will appear. These are all the network interfaces that your computer is connected to. You can choose any one of the network interface to start capturing packets from them. Let's start capturing packets from the Ethernet network interface. Once the process of capturing packets is started, all the packets that are captured will appear over here. You can select any one of the packet to see the detailed view. Here is the data link layer along with the destination and the source MAC address, and the IP header which contains the source and the destination IP address. And lastly, the transport layer which contains the TCP protocol header along with the source port number and the destination port number. You can also see the flags, which are quite important for troubleshooting and other purposes. There are some bad uses of packet analysis too, like man-in-the-middle attacks, sniffing username and password, eavesdropping. In man-in-the-middle attack, the intruder can intercept packets between two communicating parties. Let's say A and B are communicating. A sends a data packet to B. The intruder in between can intercept the packet. He can then forge a packet so as to act as it is coming from A. He can easily record the whole conversation and may even change it as he wishes. Sniffing passwords and usernames can be done by reading all the packets that are crossing the network interface and choosing the correct ones. Eavesdropping is also an unethical use in which an attacker may just want to listen to the conversation. This can easily be done by network analysis. Our next topic is packet crafting. Packet crafting is the process of creating custom packets. Most of the fields of the network packets can be edited depending on the tool you are using. Packet crafting consists of 4 steps: packet assembly, packet editing, packet play, and packet decoding. In packet assembly step, the packet is created according to the protocol chosen by the users. In packet editing step, the fields of the packet that the user wishes to customize is edited in. Packet play step involves sending the packet out of the network through the network interface chosen by the user. Packet decoding is a similar step that we've discussed, just like packet analysis. Just like packet analysis, packet crafting is also used by network admins and security specialists to test their firewalls and servers. But packet crafting gives more control as one can edit fields of the packet to target specific protocols and their problems. Although packet crafting is used for many good purposes, there are certain unethical uses too. We will discuss this in a moment. Mo- the popular tools that are used for packet crafting include Ostinato, Scapy, Hping, and others. I will demonstrate packet crafting using one of the tools called Ostinato. This is the interface that you will get once you start Ostinato. For to start packet crafting, you have to select the Ethernet network interface and create a new stream. You can then edit the stream to choose the protocols that you want to use for the packet that you're crafting. Here you can select the protocols according to your wish. Let's send an Ethernet packet that will use an IP protocol in the network layer and a TCP protocol in the transport layer. Once the protocols are chosen, you can go to the next tab to edit the fields. Here in the data link layer, you can edit the destination and the source MAC addresses. Next, we'll edit the IP header. As you can see, most of the fields over here are editable, like the version, the header length, the don't fragment and the more fragment fields, time to live, the protocol, the checksum, and most importantly the source and the destination IP addresses. Let's edit the source and the destination IP address. Next we see the TCP header. Here also we can override the source port, the destination port, the sequence number, the acknowledgement number, and most importantly we can set the flags. Once the fields are customized, we can choose how many packets we want to send and the speed of the packets. Or we can choose the burst mode if you want to send a number of packets at once. Let's choose to send 100 packets at the rate of 10 packets per second. Once all the editing is done, we can go to the next tab to view our packet. Here we can see the destination and the source MAC addresses that we have edited, the IP header which contains the source and the destination IP addresses that we've edited, and the TCP header which contains the source and destination port which we actually did not edit. Once this is done, we can apply the new edited stream to the Ethernet interface. Then we can choose the column number which is corresponding to the interface that you've edited and start sending out the packets. Once you start sending out the packets, you can see that the frame sends increases. So you know that the packets that you've crafted are being sent out now. Just like packet analysis, there are some bad uses for packet crafting too, like ARP spoofing, denial of service attacks, and penetration testing. In ARP spoofing technique, one can fool the routers and other hosts to believe that an IP address of a different host actually belongs to your machine. As a result, the packets meant for that machine can end up in your computer. In denial of service attack, one can send a large number of packets or malformed packets to a host or server. The host or server gets confused while processing the packets and eventually stops reacting to genuine users. In penetration testing technique, you can detect vulnerabilities in a server by crafting specific packets. This was my presentation on packet analysis and crafting. Thank you.